Okay, let's take a look at one more example. So express the measure of the angle in degrees. Now you are given in DMS, degrees, minute, and second, right? Let's think about these two degrees. So you are going to have that as decimal digit, right? Let me actually open the Jamboard. So here is the problem. Okay, let's use green. Okay, you have 36 degrees and 45 minutes. So 45 minute is 45 minute of 60 minute, right? So if you have a 60 minute, you're gonna have 1 degrees, but you don't have that degrees yet. So it's only 45 out of 60 minute. So you can divide 45 minute by 1/60. Similarly, 36 seconds, you can change that to minute by dividing that by 60. Then we have minute here, right? To change the minute to the degree, you need to divide that by 60 again. So we have 36 degrees plus what's 45 divided by 60? 0.75. That's also degree. And if you calculate only this part, you're gonna get minute. But after that, if you divide that by 60 again, you're gonna get degree. So you have 0.01 degree. So you can just add them all together. 36 plus 0.75. This is ones digit, tens digit, and tenth, hundredth. So 0.01. If you add them all together, it's 36.00. So 5 and 1, 6. 0 plus 7 plus 0 is 7. 6 plus 0 plus 0 is 6. 30. So it's gonna be 36 degree. 36.76 degrees. Okay. What if you are given the other way around? So 36 point, for example, 76 degree is given. How can you change this to degree, minute, and seconds? We know 36.76 is 36 plus 0.76, right? So you're gonna multiply this by 60 degrees, then it's gonna be minute. So this is degree, and this times 60 will be minutes. So let's look at 0.76 times 60. What do you get? You get 45.6. So that's in minute. So I can rewrite this as 36 degree plus 45 minute, only the whole number because we don't want to have the decimal number. But since that's a decimal number, still in minute, you can multiply this by 60, then you can change that to seconds. So we have 36 degree, 45 minutes, and what's 0.6 times 60 is 36, right? So 36 seconds. So that's exactly same as the original question. 36 degree, 45 minutes, 36 seconds. Exactly same. So you need to know how to go back and forth. Okay? Alright. Now let's move to the angles. Okay. So I talked about how to use the angle measurement there in the beginning. I actually want to show you the virtual tool. Okay, so I created the angle. You have, hold on. Okay, so you have two rays. Even if I don't have arrows here or there, let's suppose there are. So you have two rays, and there's a vertex there. So you have two sides and the vertex, and I created an angle. Looks like about 90-degree angle, but let's see. Okay, so when you are measuring with protractor, what you need to do is you have to align this 90 degree, that point in the middle, that has to be on the vertex. You see that? The vertex. And then you need to align 0 degree at one side. And look at the other side. And you're gonna measure what it is. So we start from 0 here. If both rays are here, it's just 0 degree. There's no angle. And then increases the angle. So if the ray is here, it's gonna be 10 degree, and so on and so on and so on. So it keeps going on from 0 to 10, 20, 30, 40, 50, 60, 70, 80, 90, and one more, 91. So this angle is 91 degree. It's not 89 degree, okay? So keep that in mind. And what if I start from there? Starting from there, it's still the same thing. You're gonna start from 0 here then. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 1 degree, 91 degree. Okay, so you're gonna line up with this vertex and then one side as 0 and count from there. Okay, let's do that one more time. Okay, so let's make another angle, something like that. Okay, and I'm gonna move my protractor. I'm gonna align here. So starting from 0, and I see up to here is 90, 100, 110, 111, 112. So this degree is 112. Angle like this, larger than 90 degree, we call that obtuse angle. If it's smaller than that, if it's smaller than 90 degree angle, we call that acute angle, right? What if it's 90 degree angle? We call that right angle. How about 180 degree angle? It is a straight line, right? So we call that straight angle. So let's take a look at those on my slides. Okay, so I have an example of acute angle up here, like 46 degrees, which is less than 90 degrees. So when you have interior angle less than 90 degree angle, it is called acute angle. Isn't that cute? That's why it's called acute. Right angle, an angle that is exactly 90 degree angle, we call that right angle. Obtuse angle, it's like round, it's bigger, right? So obtuse angle, which is greater than 90 degree, but has to be less than 180 degree. If it is 180 degree, it is a straight angle. What is reflex angle? Reflex angle is the angle greater than 180, so greater than straight angle, but less than 360. When it is 360, it makes circle, right? So it has to be less than 360 degree. We call 360 degrees as a 4 angle because you start from there and come back to where you started from. Okay, it's called the 4 angle. Okay. I suggest you to do such an activity with your students. It's gonna be fun and it's more hands-on and tangible. So I think it helps your students to understand what's going on. So you can, fold your paper like one time and then open it up, and then you can make straight angle there 180 degree. You can fold that again and fold hot dog, hamburger again. If you make the corner to corner exactly, you're gonna get 90 degree angle. You can make a variation of that too. If you don't make corner to corner and if you are off a little bit, you're gonna create acute angle and obtuse angle there, like this, right? So we can get to know this part. This is obtuse angle and the other part is acute angle. But look, when you're adding angle alpha and angle beta together, it becomes 180 degree angle, right? And we call alpha and beta supplementary angle to each other. Another thing is you have congruent angle here and there. right? Congruent angle here and there. So you can do a lot of fun stuff by folding the paper. Okay, supplementary angles are two angles with sum of 180 angle. Complementary angles are two angles with sum of 90-degree angles. So for example, 60 and 30, right? They are called complementary angle. How can you remember that easily? C comes before S. 90 comes before 180. So you can remember complementary angles are two angles with a sum of 90. C comes before S, and S supplementary angles are two angles with a sum of 180. Okay, now we're gonna talk about circles and arcs. I know this is a lot of information. Sorry about that, but you have learned this a long time ago. Not too long ago, because you're young, right? For me, it's a long time ago. But anyways, it's not gonna be too hard for you. So yeah, take a break in the middle and watch the video again, because I made 3 parts for you to take a break, okay, in between. All right, so circle. What's the definition of the circle? Circle is every point, all points in the same plane that lie at an equal distance from a center point. So what I mean by that is, here is the center of a circle. So from here, with radius, this distance, every point on this circle has same distance from the circle. So I can draw another radius there, still same size as this one, right? So any point you pick from this circle, from that to center is equidistant, okay? Equal distant. We more fancy name, equidistant, okay? So we call this red dot, we need to make it smaller, but anyways, that is a center, right? And from center to any point on the circle is called radius. What is diameter? Diameter is double of, yeah, some people say double of radius. More specifically, the diameter is shortest chord. So let me talk about the chord first. What is chord? The chord is a line segment that has its endpoint, both endpoints are on the circle. So you can draw a lot of chords, right? A lot of chords. Diameter is one of the chords with longest distance. Okay, so let's go over those concepts one more time. So the distance between the center and the circle border is called radius. Any point on the circle and to the center, the distance of that is called radius. A line segment that has the end point on the circle and it passes through the center is called diameter, and also it's the longest chord, and also it is double of radius, right? Okay, the diameter is twice the size of the radius, because from here to there is radius, from here to there is radius. Okay, a line segment that has its endpoint on the circle, so you can draw a lot of those line segments, they are called a chord, and of course diameter is the longest chord of a circle. Okay, now let's talk about an arc. An arc is a portion of the circumference of a circle. Hey, what is the circumference? Circumference is the length around the circle, right? Then what is the length around any other shape like polygons? We call that, what do we call that? Perimeter. There we go. Yeah, perimeter. And the perimeter of a circle is called circumference. Okay, so circumference is the length all around the circle. an arc is only part of it. Okay, so any part of the circle that can be drawn without lifting a pencil. And there are minor arc and major arc. Minor arc and major arc, of course major arc sounds bigger and minor arc sounds smaller, right? So major arc is the arc that is longer than half of the circumference. Okay, and minor arc is an arc that is less than half of the circumference. Minor arc we are notating like this, so it looks like an arc, right? Arc AB. You just need to have 2 points on the circle, like arc AB. This arc AB means not this part, because this is major arc. Arc AB using only 2 points on the circle, that's minor arc, so smaller size. Okay, for major arc you need to put another letter in between. So if you want to show this arc, we don't want you to write that as arc AB, because arc AB sounds like minor, smaller side. So we're talking about this as minor arc, arc AB. If you want to indicate this part, it's major arc AB. So we're gonna put K, any point in between A and B there. So if we write arc AKB like this, we know starting from A, the arc goes all around, passing through K and come to B. Okay, so if you see 3 letters, usually it is major arc, but sometimes even minor arc, we put 3 letters too, just to clarify which arc we are talking about. But for major arc, no matter what, you need to use 3 letters. Okay. Okay, so here's one example. How to read this one? This part only in the parenthesis is arc AB. If you have anything like italicized M like that, it means measure. So measure of arc AB. Measure of arc AB, again, that is minor arc, right? So AB is here, arc AB should be this one, because major arc is on the other side, minor arc is this one. So measure of arc AB is the same as central angle here that contains that arc. So we are finding this angle. Okay, so let's do this together. Pause the video and solve this by yourself first, okay, before I solve this for you. Okay, so find the following measure here. Measure of angle, measure of arc AB. Measure of arc AB. Whenever you see M in front of any like angle or measure of, any arc, you call that as measure of, okay? That means you need to find the measure of arc AB. So again, AB is the minor arc here, not this way around, right? Associated with central angle AOB, which means measure of arc AB here is the same as the angle here. So you are looking for the angle. This is same as measure of angle AOB. That's what you're looking for, AOB. Okay, how do we find it? Well, we know this side here is 60 degree, and we also know this is a straight angle. Then 60 degree here, and that should be supplementary to each other. Using angle addition postulate, this plus that should be this, right? So we know 60 plus that, what we are looking for here, should be 180 degree. So we know that is 180 degrees minus 60 degrees, which is 120 degrees. So measure of angle arc AB should be 120 degrees. Measure of arc AF. measure of arc AF. Okay, measure of arc AF. AF is here. Again, it's minor, right? And we know the angle should be 60 degrees. So it's gonna be 60 degrees. How about this? Measure of arc BC. Measure of arc BC. B is here, BC is here. Hey, take a look. This angle here and that angle should be same. That arc and that arc should be equal. We call that vertical angles. So this angle and that angles are congruent using vertical angles. We can prove it too, because we can make a straight angle here. Then this plus that is 180, so we know this should be 120. By looking at this side, this straight angle, we already found this as 120. 120 plus 1 makes straight angle, 60. So we can find it out. This is also 60 degree angle. So we can show the vertical angles. We call this as vertical angles, okay? Vertical angles are congruent. So we know BC, measure of arc BC associated with central angle BOC is also 60 degree angle. How about measure of angle FDC? So it may be major, but let's see. F is here, D is here, C is here. It's not actually major arc, but to just make it clear, they put another letter in between. Okay, so measure of angle FDC has to be associated with the central angle FOC. So this angle it's asking, right? Again, this and that has to be vertical angle to each other, so congruent, right? Or you can use other angles like 60 to make 180 straight angle. You can get to know this is also 120 degrees angle. Okay, so I think that's kind of easy. What do you think? Okay, so we just talked about the vertical angles, right? Vertical angles are the pairs of opposite angles made by intersecting lines. Okay, so the vertical angle theorem, the vertical angles, two vertical angles are congruent. This and that are congruent, this and that are congruent, and I just proved it, right, in the previous example. Perpendicular lines. Perpendicular lines are very simple. Two lines intersect with a 90 degrees angle. Then these two lines are perpendicular. What's the parallel lines? When there's no intersecting points between two lines, right? Okay, keep going. Line perpendicular to a plane. A line can be perpendicular to another line, but it also can be perpendicular to a plane. So when this line and this plane meets a 90 degree angle, they are perpendicular to each other. Then think about it. All lines here, any lines on this plane should be also perpendicular to that line. Okay. To finalize this, I'm going to go over a couple of questions. Okay, I think it's from your homework or quiz or something. I don't know, I forgot. But anyway, you can find this from the My Math Lab. So let's copy this and go over here. Okay, so this is your original question. Okay, the first question using this diagram is, which of the following is the intersection of segment BE and segment AD? So segment BE is here, the perpendicular segment to the plane, the bottom here, ACD, right? So segment BE and segment AD, do they intersect? If you extend it, even if you extend it, it doesn't meet together, right? So we call that these two line segments are skewed to each other, which means there's no interaction. no intersecting, so it has to be an empty set. Make sense? Okay, let's look at the second one using the same graph. Let me get rid of this. Okay, how about this one? Let me also erase this. Okay, so which of the following is the intersection of a plane ABD, plane ABD, ABD? So we're talking about this plane. So this side of this pyramid. Okay. And ACD. ACD. Let me use this color. ACD is bottom here, the base. These two are intersecting, right? Where do they meet? They are meeting right here. Oops, let me change the color. Thickness. Right here. They are meeting this. So if you are thinking about the net, by opening this up, you get to know this side of this triangle and this side of this triangle intersect. They meet there. So AD. Line AD. Two planes meet at a line, right? Let's look at next problem. Okay, I think I can do it this way. Okay, so part C, which of the following is the intersection of BE, segment BE and BD? Segment BE is right here. Segment BD is right there. By just reading this, we get to know intersection is the point B, right? They meet at this point. So point B. Okay, how about this one? Hang in there, we're almost done. Okay. Let me copy one more last question here too. Okay, so let's do both of them. Okay, let's look at this first. D. Which pair of lines are parallel? So let's take a look at the first thing. Line BD and BC. BD and BC, they are intersecting at B, right? So it's not parallel. They have intersecting. AB and AD, we get to know already A and A. So they intersected A. This one, they intersected point B. How about AB and BC? A, B is here and B is there. So AB and BC, they intersected point B, right? And it seems like the figure contains no parallel lines. Okay, how about this one? Which pair of lines are skew lines? Let's see. AB and BC, again, B, B there. So they are intersecting, right? So skew lines, they don't intersect. And they are not parallel. AC and BD. Line AC is back there. BD is in the front. So can you imagine that? Even if my drawing here is intersecting because it's two-dimensional, but actually this is three-dimensional. And the dotted line here, this one is in the back, but this one is in the front. So there's a gap between them and they don't actually intersect, right? So that is skewed. How about BD and BE? Hey, B is there, B is there, so they are intersecting. How about AD and CD? They are intersecting at point D. So I think you can easily find the answer for that. Okay, one last question. I think this is very helpful for you to solve some problems in the homework or quiz. or test. Okay, so let's do this one because this is a little bit tricky. I thought I can help you a little bit. Okay, so here's a question. Measure of angle AOB, which is x. That's an x, so you need to find the x there, right? Do you see that x? And measure of angle COD, COD is y. So you need to find COD and AOB, x and y. But you are given this. Measure of angle AOB is 1/3 of COD, which means this is 3 times bigger than x, or this is 1/3 times of y. So we know that there's a relationship between x and y. X is 1/3 of y, or y is 3 times x. Either one, okay? We know that. And also we know this is 90-degree angle. So if I put 1/3 of x here or the other way around, I don't like fractions so much, so I'm gonna change x to 1/3 of y. Okay, then I'm gonna get fraction actually. So I can do the other way around. It doesn't matter. So let's just keep it. But anyways, 1/3 of y is this, and that's y degree here. And that's 1/3 of y, and this is 90-degree angle. And we also know this is a straight line, so straight angle. When you add this angle plus that angle plus that angle, it's a straight angle. So using angle addition postulate, we get to know 1/3 of y plus 90-degree plus y should be 180-degree. Let me say this again. So x plus 90 plus y is 180, but that x is same as 1/3 of y because we got that from here. So we know this is the same as 180. Now it's an algebra. What's 1/3 y plus 1y? 1 plus 1/3 y is 1 and 1/3 y plus 90 is equal to 180. 1 and 1/3 y is 4/3 y. Right? To solve this, you can subtract 90 because it's added. So subtract 90 on this side to make it equal. You're gonna do the same thing on the other side. Then this is gone, and you have a 4/3 y is equal to 180 minus 90, 90. How can we solve for y? Since it's multiplied, you can multiply the reciprocal to the fourth. You can do the same thing on the other side. Then this is gone and have 1 there. 1 times y is y, and you have this. To simplify this, I know this is divisible by 2, which is 45. And what's this? 3 times 45 is 3 times 5, 15. 3 times 4, 120. So 135 over 2. So y is 67.5. If y is 67.5, what is x? X is 1/3 times y. So if this is y, your x should be 1/3 times y. So x is 67.5 divided by 3. And what do you get? Let me use my calculator. What's that? So whatever you get there, I don't have my calculator with me right now. It's the battery is gone. So get that, okay, and that should be your answer for that. Okay, I think this will help you solving the problems on the homework, quiz, and even the test. So good luck everybody, and hang in there. We are done a lot of stuff, and you are doing really good job. So yeah, hang in there, and I will see you again for the chapter 11 section 2. Okay, bye guys.